So the question is, the shortest wavelength of hydrogen atom in the Lyman series is lambda 1. So the longest wavelength in the Balmer series of helium ion is. In order to solve this equation, we need to first know about Rydberg formula, which is 1 upon lambda equals r z square bracket 1 upon n l square minus 1 upon n h square. Here R stands for Rydberg formula, Z stands for atomic number, NL stands for lower energy level, NH stands for higher energy level. So we will first put these values according to hydrogen atom. So the atomic number of hydrogen is 1. So we will put 1 here, and we will refer the series to put the energy level values of the lowest state and the highest state. In this case, the highest state of the hydrogen level is infinity. And then we will do the same for the helium. The atomic number for the helium is 2, and its lower energy level is 2 and higher is 3. And similarly we will get these two values, and after dividing these equations and further simplifying it, we would get lambda 2 is equal to 9 upon 5 into lambda 1, which is the required answer. The answer is option 1.